Welcome student to this new chapter. We will do applications of differentiation. One of the most important applications of differential calculus, we mean by it's the derivative. So we have studied the derivative, we know how to find the derivative. Now, what is the application of derivative? You will find the most important one are in optimization problem. Now, what is optimization problem? Optimization problem is finding the optimal, and optimal means the best way to do something. So we have a problem that we need to optimize to find the optimum solution. In our cases, these optimum solution or those are best way are reduced to find either minimum of something and maximum of something, and of course that will be related to functions because we are doing derivative of functions. Let's see one example from the business application. One of the first example, you will understand that if we have the revenue, which is the money that we get back from the customer after we sell an item, we need to maximize it. We need to get the maximum revenue. So we ask ourselves how many product we need to sell to reach this maximum revenue. Sometimes I just want to get a return. Remember, return means the profit is positive, which means whatever I get back is more than the cost of the product. So I need to know what is the least, what is the minimum quantity so that my revenue will be more than my cost. Those are legitimate questions for any company, for any business. And this is the way that the business can thrive if they know how to maximize their revenue, they minimize their cost. Now, in our topic today, first of all, we will learn to find something we call them critical points and the critical numbers. Those critical numbers are very important. For the first question is how to find the extrema. Extrema means how to find local maximum and local minimum, absolute maximum, absolute minimum. How are we going to find them? We find them using the critical points. So first of all, we need to find the critical points, and then we will check if it is correspond to a maximum or a minimum. How do we find the critical numbers? We have two cases. Either we make the derivative equal to 0, or we try to find where the derivative does not exist. Where do we have a problem with the derivative? And usually we have a problem if we have denominator. And we know that the denominator cannot be equal to 0, so there where the derivative does not exist. Otherwise, we will stick with the first case, which the derivative equal to 0. Important note, these critical points are just candidates for local maximum and local minimum. We don't know if they are maximum, we don't know if they are minimum, we don't know if they are neither of them. So let's first focus on critical numbers, focus on this rule. Let's see many examples how we find the critical numbers and the critical points, and then we will see how we can classify which one is maximum, which. Welcome student to this example here, example number 1, where we need to find the critical numbers of the following functions. So just to remind you what a critical number is where we have the derivative f prime of x either equal to 0 or the derivative does not exist. So if we have denominator, we need to see where the derivative does not exist. Now, in order to solve this question, the first step we need to find the derivative, and then we will see what we can do with this derivative. So in this example, it will be 3x squared plus 2x negative 1. Now, the first case where the derivative does not exist, this is not happening. And the reason, we don't have a denominator. No denominator. Now, if we have denominator, or if we have anything that make the derivative does not exist, then we can investigate this further. Now, after our equation, all what we need to do is we will make the derivative equal to 0. Now, we can solve this one using the quadratic formula, or we can use the calculator mod 53 to get the answer for this question. So the answer will be x equal -1 or x equal 1/3. So the critical numbers are just -1 and 1/3. So those are the critical numbers. Again, just a recap of what we did. We need to find the critical number, and there is two cases for critical number. Either derivative equal to 0 or the derivative does not exist, which means we have a problem somewhere in the function. And one of the problem, if we have denominator, which we don't have in this function, anything that will make a problem. So we just focus on making the derivative equal to 0, and then we solve it using factoring, quadratic formula, or the calculator. Let's go part B. Now for part B, we will have the same situation. Critical number means either the derivative equal to 0, or the second case, if a prime of x does not exist. Let's find the derivative, and then we can see which case we can deal with this function. This will be 6x squared -6. Again, this is not happening here. And the reason why, there is no denominator, there is no any problem with this function. So the only thing we will make is we take the derivative and we make it equal to 0. This, if we solve it, it will be either x equal to 1. Of course, we can solve it by factoring, or we can solve it by the quadratic formula or the calculator. So it will be 1 and -1, and those are the critical numbers. Of course, the good thing is we always can check our answer is correct. If we substitute x equal to 1 here, the answer would be 0. Again, if we substitute -1 here, the answer will be again 0. So this is always can be verified and checked accordingly. Next question is, again, we need to find the critical number for this function. However, this function, f of x, we can write it as outer function, which will be the square root, and inner function, which is this one. Now, in order to find the derivative, remember we will use the chain rule, and the chain rule goes like this. First, we take the derivative of the outer, which is the square root, and the derivative of the square root is 1/2 square root of x, but we don't have x here. So instead of x, I will just write 1 minus x squared, and then we need to find the derivative of the inside, which will be -2x. So all in all, what we will get is 2 and 2 will get cancelled. So we'll get in the top -x, and in the bottom we have a denominator. Now to find the critical numbers, either we make the function, the derivative equal to 0, or the derivative to be does not exist. Now, when are we having the derivative equal to 0? It means the numerator must equal to 0, and that's the only place where we will get a 0. What is the numerator? It's just -x equal to 0. So x equal to 0 is one of the critical numbers. Now, when we are going to have the derivative does not exist, if the denominator equal to 0, which will be this one. Now, if we solve this one, we can square both sides, and then if we solve it, x will be -1 and x will be equal to 1. So we have 3 critical numbers, and here they are. So remember in this question, because I have a numerator and denominator, to find the critical number, each one of them must be equal to 0. Let's go to the next question. Next question, we have to use the quotient rule. So we will use the quotient rule. Now, what's the quotient rule to find the derivative? It goes like this. Denominator square, denominator times the derivative of the numerator, which is 1, because derivative of x minus 1 is 1, minus numerator, and then derivative of the denominator, which is this one. And now we just have to continue with this one. Here we'll have x squared minus x plus 1 minus, here we'll have 2x squared minus x minus 2x plus 1. And we just need to continue this. Here we get x squared minus x plus 1 minus 2x squared minus plus x plus 2x minus 1. Now we can do the final simplification accordingly. If we do the final simplification, it will be minus x squared plus 2x, and that's the remaining thing. Now, in order to find the critical numbers, we need to find where the function, the derivative is equal to 0. So f prime of x equal to 0, and where the derivative does not exist. Does not exist. Now, the derivative does not exist. It means the numerator equal to 0, and the numerator is this one. Which means only whatever inside the bracket is equal to 0. And this, if we try it with the calculator and the formula of the quadratic equation, will give me no real solution. No real solution. If you try it with the calculator, you will get I, which means it will give you complex solution. So no real solution. The only other case that we need to take care of is when the numerator equal to 0. The numerator is minus x squared plus 2x equal to 0. Take x as common, or just use the quadratic formula to find that x equal to 0 and x equal to 2. So those are the only two answers where the derivative is equal to 0 here. And that's it for the quadratic. For the critical numbers, we use the quotient rule in the last